Okay. Now let us actually diagrammatically try to plot a AR1 process and a MA1 process. Okay, so let us say this is our AR1 process. I'll write AR1 process. I plot here, let me use a different color. I plot here lag, and I plot here, say, my correlation coefficient. Normally I represent it as rho for a, say, lag, lag h, okay, rho h. And I do another plot for my MA1 process. MA1 process. I have my lag in the x-axis and my correlation coefficient on the y-axis. Okay. Now, if I plot my, let me also write down the value of the phi operator and theta, operator and theta operator. Okay. So here I will write phi operator. Say, for the sake of consistency, let us write the value of phi operator and theta operator to be the same. Okay, let me write down this. Now let us plot the ACF, okay, or the autocorrelation, the correlation coefficient for different values of lag. Now what will happen for this one? Now we know the value here is nothing but phi power h. Okay, so that is the value we get. And whereas this one is going to be, my value is going to be how much? My value is going to be the for, actually I have different values for different lags, right? So we'll write it down. Let me first plot this for AR1 process. Okay, so if that is my autocorrelation coefficient, the correlation coefficient is equal to rho power h, so that means the first one would be here, which is basically value would be 0.9, right? The second one would be here, 0.81, right? I'm basically doing square of this. Third one, you multiply 0.9 with that, a little bit of decline, and so on and so forth. It will go on like this, right? So you will have something like a plot, you will get something like this. So it means you're getting exponential sort of curve, right? But for in the case of my MA1 process, I know that they have specific values, right? And I will take the value for h equal to 1. Let me just write it down. For h equal to 1, this is very specific, 1 theta by 1 plus theta square. I'm not taking the value of h equal to 0. That means just you're taking variance. So I'm really not bothered about that. I need the value for h equal to 1 or a bit more, right? Now for h equal to 1, I get this value, means if I have 0.9, so what I get here is 0.9 by 1.81, right? 0.81, so which means almost like slightly less than 50%, so like 4, 9, something 7, something like that will come up. Okay, you do the maths. So that's the value you get. That's the only value you get. So basically I have, say, my lag period 1, L equal to 1. Here I'll write 1. So here also I had this lag periods 1, 2, 3, 4 and so forth, and up to h. Here also I can write h. Now for this one I will have only this value, right? So here I have, say, something like 0.49, okay, 497, whatever. And that's it, basically. You don't have any more value. If you have h equal to 2, it will be 0, h equal to 3, any value you take, it's basically 0. So that's the difference. So you see, for AR1 process, you have this autocorrelation structure you will get. You can see the lags, and you can actually see how that graphical representation will look like. And this one, you are going to see something just very unique here. Okay.